In this video, we'll see how GraphDB's virtualization feature uses the OnTop tool to treat a relational database as a virtual triple store dataset so that you can send Sparkle queries to that relational database. This works with a variety of relational database managers. For this video, we'll use MySQL. We're going to use a database called Ontotext that has two tables. The depths table lists department names and ID numbers, and the emps table lists the employee ID, given name, family name, and department number for several employees. At the MySQL prompt, if I want to list employee names with their department names, not their department numbers, I can use an SQL command to do a join between these tables. We're going to see how we can do this with a Sparkle query from GraphDB. For GraphDB to communicate with a relational database manager about its data, it needs at least two things: a JDBC driver and an R2RML or OBDA mapping file. A JDBC driver lets other programs communicate with a database manager using a standard Java-based protocol. This is something that the database manager's vendor provides. Once you download it, the GraphDB documentation lists several options for where to put the JDBC driver so that GraphDB can find it. A mapping file tells GraphDB what data to pull from the relational database and what the RDF that it creates from that data should look like. There are two formats you can use: R2RML, which is a W3C standard, and the OnTop tool's own OBDA format, which is more compact. Here we see an OBDA file called empdept.obda that has two mappings. For each mapping, the source is a simple SQL query. For the first mapping, this query retrieves all of the data from the empdept database's emps table. The mapping takes the names of the columns in that table, like emp ID and family name, and plugs those names into the target pattern, which uses them to create RDF triples. The second mapping specifies the depths table as a data source and shows where in the triple patterns to put the dept ID and name values from that table. With our JDBC driver and mapping file already, we can use them to create a virtual repository. We go in GraphDB to the Repositories tab and pick Create New Repository. Instead of picking GraphDB repository, as we would for a regular repository for RDF triples, we'll pick OnTop Virtual Sparkle. We'll call our new repo virt1 and enter a username and password that gives us access to the MySQL database. The three remaining required pieces of information are the driver class, which is the name of the class to use in the JDBC driver file mentioned earlier, and the JDBC URL, which is in a format specified by the database vendor. Note that it includes the name of the database that we're querying at the end of the URL. And finally, the OBDA mapping file, which we saw earlier. We can test our connection to check that GraphDB has everything it needs to communicate with a relational database manager, and then click Create to use this configuration to create our virtual repository. We then see our new repository added to the repository list and click to connect to it, and we're ready to query it. Our first Sparkle query to send to the Relational Database Manager just asks for all the triples. In the result, we see the data from the relational database. Our next query is a Sparkle equivalent of the SQL join that we did earlier, showing each employee's given and family name and the name of the department where they work. Note how the query asks for the department number but doesn't display it in the results. It uses these values to look up the department name, which do get displayed in the result. And there they are. This last query counts up how many employees are in each department. Like any other GraphDB repository, a virtual repository also functions as a SPARQL endpoint. This curl command sends a query to the endpoint that goes with our new virtual repository. The query asks for 3 triples, and there they are. In addition to working as a SPARQL endpoint, you'll find that these virtual repositories can take advantage of a wide variety of features that you are accustomed to using with a regular RDF repository. If you have access to any relational database managers, GraphDB's virtualization feature can use their data to contribute a lot to your knowledge graphs and applications.